Pardon me while I setting up, doing the setup, setting the up. You know? What? A cartoon ape in a jungle who likes to make games like the one down below. I get tired of doing the same intro, so making it up. Yeah, there's a game down below. You can play. Go for it. In this series we call Design Chat, where I am supposed to be visible. Pardon me. Oh, did I just... Bro. Pretty jungle, but not what we wanted. No, no, no. Try that again. Whoa. Oh, I see what happened. Okay, yeah. Hotkeys can work against you, too. Got it. Understanding. Okay. Setting up. Totally setting up right now. Yeah. Hotkeys can work against you. Yes. Got it. Understanding. Okay. I was going to say, in this series Design Chat, we talk about game design because the assertion is that anyone can do this. I'm going to assert that. It's true. And we said, well, you know, if you're freaked out that you don't know art or code or story, you know, and you're like worried that you can't make a game because you don't know these things, well, I say, you're good. You don't need to know these things. These things are not necessary. And we proved it. We said, well, actually what things are necessary, like player control, a win-lose state, and some rules of the game that the player can agree to, these things we should do, and therefore here's a simple game. Without any art or code or story, here's a game. We said, it's this square, and you can move up, down, left, right. That's the modest amount of player control. We're good. And then there's this win square. If you get in there, you win. And that satisfies the win condition. If this square shrinks, and then you can't win, and you lose, well, that satisfies the lose. You see. And so if these are the rules that are, you know, understood by the player, then we've satisfied all the conditions, and hey, we got a game. So what we've been doing now is using our other series design workshop to actually build this thing. Now, so far, we have this. We have the modest amount of player control on a player character that is a square, but we've done a little bit of art. We've done some art to make it look like a thing. It looks like this thing. It's, you know, not much, but it's something, right? So as you move around, our character kind of looks like this, and that's cool. And to do this, we've said, well, we need to do some art. So we made frames like when the character is still, the character it wins, we're going to do a happy face. Hey, you know. We did some frames of animation, and we put it on this square. So it's not just a square, because we recognize that one of the questions the player's going to ask immediately is, who am I? And this square doesn't quite cut it, but this does. This works great. Ooh. Now, in the design workshop, we have not done anything with the win square yet. It's actually got quite a bit of rules to it. In fact, what we have talked about in Design Chat is the systems of this game. It includes the player control system. That's the up, down, left, right. That turns out to be a little more complicated than that, only because once we played it, we realized, oh yeah, the player kind of wants to go like diagonally sometimes too. Wants this nice, easy, flowy kind of movement. In order to do that, up, down, left, right really doesn't cut it. So we just changed the rules to make it a little more flexible, and then we implemented that in Design Workshop. There's an animation system. The character animation system does two things. One is it blinks every once in a while. And the other thing is it handles which frame we're showing, because, as I mentioned, it looks like this while we're moving, it looks like this when we're not moving, etc. And so for each of these systems, it's nothing fancy, it's just a list of rules. Right? Follow these rules and the player control does its thing. Follow these rules and the animation system does its thing. What we find is that the designer's job is to stick around and adjust these rules as we find we need new needs. We had up, down, left, right, and then we played it and said, oh, wait, no, there's a need to at least have some smooth movement in like a diagonal direction if I hold down W and D at the same time. So that caused us to go back in and adjust these rules to accommodate that. And so in our design workshop, we could change the code to fit the rules, and there you go. And this is how the designer works. The designer sticks around. The designer evaluates how it's going through testing, and the designer comes in to modify the rules of the game further to accommodate new needs that we hadn't thought of yet, to fix problems that we didn't see until we get here, to take opportunities that we didn't realize were there. A minor opportunity, well, we have these blinks. The animation of blink is really just a frame. And we have this frame of like looking at you, and then we have a frame of a blink, and we kind of switch these two frames, and it's just on a little timer.
Ladies and gentlemen, welcome.
It's so nice that people come by and follow. It's very cool. And the rules of our chat stipulate we are not going to buy anything. And I appreciate you, but we eat bots around here. So the blink frame is kind of cool. It waits a little time, and it blinks, and then this timer is much shorter, and then goes back to normal. Well, that's cool. One small opportunity we saw was when we blink fast, it's actually kind of expressive. It feels like the character is just sitting here, but it's kind of like calling attention to itself. It's neat. And we thought, wouldn't it be cool if at the beginning of the game we kind of blink a few times quickly and then do the normal open eye for a while and then blink and open eye for a while, you know? So there's small opportunities we didn't see until we started, implementing more of this. This is why the designer sticks around. This is what the designer's job is. It's great if we can think of all kinds of opportunities ahead of time. It's great if we can head off the problems ahead of time. But that can't always happen. And it's better to think of it like the design process allows us to always improve, right? Design process was something else we've talked about here. And we go through this process to say, let's look at all those needs the player has. Let's think of the ways we could address those needs. Let's find the best one to follow. Let's test it out. Let's evaluate the results of that test. And then with that new insight, go back and do it all over again. Always improving if we do this over and over again. So this follows the design process. This is what we're supposed to do. This is how it works. So we had a simple game idea, and now it's more complicated. Well, yeah. And it's more complicated in a way that actually meets needs we didn't see until now. The player's experience is still king. Our our minimum requirements to make a game are still there. It's funny that we did add art, but a lot of what we're doing to improve the game has more to do with how the player feels about what's going on. And it's true, we haven't done anything with the win square yet. It's true. Not in Design Workshop. The rules for the win square are pretty well understood. We know that there's more of them than for the player. But just looking at the player character movement and the player character animation, we found enough in these systems to try and improve. Now, the player control actually looks pretty good. The movement of this player character is actually pretty good. The character animation was not so great until last time it started to come together. Hello. It's so nice to have people come by and follow, and yet the rules of the chat stipulate that we will not buy anything and we eat bots here in the jungle. So, here we are. What we can say is, because this is the role of the designer, we are looking for opportunities. We're actually also looking for issues or problems to solve. It's all centered on the player experience, and so as long as there's some need we can address, we go to town. Right? We keep looking for these needs. And isn't it interesting that we haven't even put together the win square yet? In fact, the win and lose condition is not part of what we've been playing with yet. The testing we've been doing has all been centered on this part of the game. And what does it mean to have just this testing place where we try to find opportunities, where we try to head off problems? Well, this is absolutely part of the designer's job, especially early in the process of making a game. Till we get the win square, I'll call it early. See, the thing is, when you have a player, you can ask the player in some ways, how's it going? What would you expect? What do you anticipate? What do you want to see? Pardon me while I pop open our design workshop to sort of talk about this further. Yes, it is the Unity engine. Even if it is us pretending that we are the player, it's helpful to ask the player, what do you need? Right? In one way or another, we ask, what do you need? And if there's a problem, the need is, get rid of the problem. If there's an opportunity, we tend to think of those as needs, just to simplify it and say, oh, that's something we have to go chase down. To have a space where all we're doing is looking at one feature or two features together, in this case, these two definitely talk together, and we're looking for those opportunities, we're looking for those issues. This is testing and more testing and more testing, because we're like stuck looking at this loop and saying, like, let's find more needs. And we're kind of doing this until we run out of needs to go address. What does it mean? Well, this is called prototyping. This word is an important word in our process. A prototype is a test, but prototyping is the testing process. Let's continue down this road. This vocabulary word, prototype, means test. it means to test as well. This is a verb as well, to prototype, but it's also a noun. We can have a prototype. In this case, what we have been doing is prototyping. We've been prototyping the player control. We've been prototyping the character animation. We've been testing. And this word can also be applied to the scene that we have been working in. It's a test scene. It does not have the win square yet, so it's technically not a game. What is it? Well, it's a prototype. This is a prototype of the whole game, sure. But we can also test or prototype one feature. In fact, we often do this. I can paper prototype. That's what we've been doing here on this GIMP page, We can paper prototype, imagining that we are the player going to the win square, imagining the win square disappears. And paper prototyping like that helped us figure out all kinds of problems very quickly. Rapid prototyping is a form of testing that is meant to be as fast as possible, and we do it by simply looking for all the things that take up time and not doing those. Right? One big thing that takes a lot of time, well, it's implementing it in the engine. And if we don't have to, if we can just sketch it on paper, this is fast. This is rapid prototyping. Absolutely. Rapid testing. And the test that we can do helps us see and helps us to evaluate and see insight to find more needs. You see where this is going. Well, this then is a scene that we have been making. We called it the game scene, but you know what I'm going to do right now? Excuse me. I am going to save as and make this a prototype scene. Character move prototype. Literally, let's just rename it, because this character move prototype scene is the better way to think about what we're doing. In this scene, we don't have a win, but we do have this character. And what we've been doing is playing around with the animation system and the movement system together so that we can move and see it blink and see the animation frames change based on how we're moving. He's pretty cute, right? When we stop moving, he looks at us. Right? It's cute. But this is not a game. It is literally testing to find issues and opportunities with this system. Later, I think we should have a game scene. Absolutely. There's nothing wrong with this being the game scene, this being the prototype scene. But I did want to point out that, it would be smart for us to have a set of scenes that are meant to be prototype scenes. That if we keep them separate like this, in fact, this sample scene would also be a prototype scene. This is where our coin was, remember? Right? Where we were doing just some mechanics and testing, frankly. We were throwing together mechanics so we could do pixel art animation, and we could move around, and we could test these things, yeah? All right. Well, that was cool. And it was definitely testing, so let's throw that in the prototype folder. Sure. This could be the game scene for later. Yeah. Let's look at the prototype scene, though, because that is what we're doing. We haven't totally developed all these scripts yet for the player movement, but it's coming together. And it's coming together because we're able to test. Find issues that the player might have with this, and we, are fixing it and making it a little bit better as we go, right? For example, our moving in a diagonal direction hasn't quite been figured out in terms of how should our little guy look. When I'm going up and to the left, I'm just showing left. If I'm going down to the right, I'm just showing right. In fact, whether I'm going up or down, I'm just showing the left or right direction, you know? Is that good enough, you know? Maybe, you know? Is there an opportunity to make it better? Maybe, you know? And so this prototype scene is a testing scene that allows us to ask these questions in isolation. We're not worried about messing up anything else or being confused by other features or conditions. We're just looking at this. We're focused on this, yeah? One of the things about developing a good test is being able to evaluate clearly, and clearing away the distractions is a good way to do that. So I wanted to sort of bring up the idea that what we have been doing is prototyping. Right? As part of the design process, we do test. And another word for test is prototype. That this is part of the process further supports the idea that making games is not some magical thing where you sit down and go and suddenly game. And it's like AAA, and it's like got all the art code and story in it and blah, blah, blah. No, dude, it's a very... The end product is complicated, and we get there with a bunch of small steps over a long period of time. Take some patience, some care. And we've been taking care. This player control movement is looking sweet because we spent time on it. It's only this, but it turns out it's actually a little more complicated, and the result is pretty cool, and we're kind of feeling good about it. That movement feels really good. This character animation, maybe it needs a little bit more, but it looks okay right now. At least in this prototype stage, it is looking pretty good. I want to bring up a topic that we will follow up in workshop, because this is prototyping and we're looking at it for opportunities, right? We are expecting to improve all the time, right? We've already gone in and tweaked this thing and made it great. And we are already changing our animation system to make it better. And here's one common thing that happens while we are prototyping. We are throwing it together to make it work, and then we realize it could be better. That happened with our player movement. We threw together our character animation and then realized it could be better. I mean, first of all, we had to draw the frames here in GIMP, and then we brought it in. I'm drawing with my mouse right now. That's why it looks so terrible. Then we brought the frames in, and we sort of anticipated what we might need for this system. And then we sort of said, oh, that's right. We don't have a left frame. We were expecting to flip it around, for example. We have a blink frame for every... Like, while we were drawing, we said, oh, wow, we want blink for every frame. Like, as we go, we realized there were things, some steps to the process we wanted to insert. In other words, again, we didn't think about all the things we needed ahead of time. We used the process. This design process says you are free to start because you can always change it and improve it later. Okay. Always improving, right? That is a mantra. That is something we count on. That's why we are safe to just start. That's why we can rely on this process to just get better. That's why we can kind of relax when it's kind of not great yet, right? Always improve. That's what this design process gives us, yeah? Well, cool. I am feeling good about the player control. I am thinking the character animation could be better, and more than just the result, like of going diagonal and those details. I actually think the improvement part is behind the scenes. The improvement part for this system is actually in the rule set that we have developed in a way that was sort of like we did a couple of rules here, and then we realized, oh, wait, there needs to be one here, and so let's shove that in there, and then, oh, yeah, wait, let's not do it that way. Let's do it this way. I mean, this is a mess. The rules alone is kind of a haphazard mess because of the rediscovery of like, oh, yeah, blink frames and turning left, and, oh, that's right, there's diagonal now. And so there was a whole lot of adjustment we had to do while we were building up just what we have right now. What we have right now actually looks pretty good. This prototype is demonstrating what we want to see. Most, like 90% there. I mean, I think it's pretty cool. However, behind the scenes, in the code specifically, but the code is just a reflection, it's an implementation of our rule set. The rule set is a mess. It's a total mess. And so you should be asking, so what? You should totally be asking, well, but so what? It actually looks great. Like, who cares? Who cares what it looks like behind the scenes, right? Go ahead and make it a, dumpster fire of a mess behind the scenes. Because the forward-facing presentation is pretty cool. Fair. Totally fair. Yes. Now, any programmers out there will be freaking out right about now and saying, no. And what they understand, the reason why we should care about this, is because of the design process, as a matter of fact. We rely on the design process to always improve. We expect the design process will lead us to see improvements, either things to fix or opportunities to take. We will expect to make changes. We will expect to make changes that will allow us to improve. So, but this looks great. It's true. And yet we are already talking about things we might change with this system of animation. Like, the movement's great, but the animation system looks good and yet is likely to be better, if nothing else, for the things we've already talked about. What I'm saying is, we have to expect we are going to make changes, even to this thing that looks pretty good right here. This prototype is a test, and it does look good, and it is representative of what we'd like to see, and yet we can expect to change. This is important. If we expect to change, let's not make it difficult for us to change. If it is difficult, we should spend a little time to make it easier for us to change, otherwise known as maintaining the feature. We can expect to change. We should make it easy for us in the future. Let's spend the time to make sure it's easy. And here is why. If this looks great, our player movement stuff is looking pretty sweet, and it's actually pretty neat and tidy. And it is. Like, the rule set plus our implementation is actually pretty clean. There might be some improvement later, and if so, well, no big deal. The design process says we should, and this will be dead simple because this is already pretty clean. If we need to add a rule, cool. If we need to change a rule, no problem. It's pretty clean. But let's contrast that with this system that is already quite a mess. Now, we've already made changes upon changes upon changes, which is why it is a mess. Now, it's fine because we're just prototyping, and so doing this and then adding this in there and then highlighting this and combining these two and highlighting, I mean, this is a total garbage dump. It's crazy town. And now when we need to make changes, I mean, we've already seen this. When we need to make changes to this, it gets harder and harder and harder. In fact, some of the things that I can see that we'd want to fix are simply like two things we did that are contradicting each other that actually could be simplified into one simple thing. And if it is simple, like this one, then it's easy to change. If it's a mess, a total rat's nest, a total, then it's harder to change. The point is, our prototyping often looks like this. Our prototyping often does testing and getting there and trying to figure out and answer the question, how are we going to make this thing? And yes, it looks like this all the time. And so to stop and say, okay, it looks pretty good, but behind the scenes, this is a mess. At least the rule set could be cleaned up. And then we can clean up the code to reflect that. And then when we need to make changes in the future, it'll be so much easier. In a way, we've been finding our way on how we're going to make the animation system, and we've been doing that through testing. At first, we just had the still frame, this frame right here, and we moved that around, and then we added blink, and then we added this movement frame. I mean, we haven't even added the happy face when they win, or the sad face when they lose. We haven't solved other issues that we can kind of see coming, like the diagonal stuff. And if I have to continue to work with this mess, it's going to get harder and harder and slower. And like I said, there's already cases where we had one thing in place and we just shoved something else in there that is totally contradicting. It's a mess. To go back through something that is looking okay, it functions as it should, like the animation system does. This actually looks fine, I play this, and it looks kind of like what we want. To go back in and change behind the scenes, even though this should stay the same, like this functions as it should, keep the functionality, but behind the scenes, the code and the rule sets are a mess. We should clean that up. To do this action, where we make it simpler for ourselves to change in the future while keeping the functionality exactly the same, is something we often have to do after prototyping and this mess that we made. It's called, this is another vocabulary word, it's called refactoring. To refactor is to maintain and keep the functionality we have. An animation system is looking good, but it is a mess behind the scenes, and it will be difficult to maintain. It will be difficult to make changes and improvements which we can expect to do because we are always improving. What we will do in our workshop is refactor our code especially such that it is simpler and straightforward. This contradiction, for example, these rules that are totally contradicting each other, we will untangle that. We made some assumptions. I think it's going to be this, and then we're going to do this, and that way it does this. And then we realized, oh, wait, we have this going on. And this is complicated. And so let's fix it this way for now, and we'll move on. Well, now we've moved on. We now need to come back and look at this. And we have to expect we're going to improve later. We need to refactor. This prototype is cool. It looks appropriate. It is representing what we want to have in our animation system for a character. Cool. Behind the scenes, though, this rule set is a mess. And I know we're going to make it simpler if we just look at the rules. So let's look at that. The animation says, currently, we are paying attention to whether or not we are blinking. This is a thing, and this is so much easier to look at the rules now that we've already done this prototyping. is blinking is a question that we keep track of. We know whether we are blinking or not. And it helps us because if we are blinking, we stop blinking. And if we are not blinking, we blink. When the timer is up, we switch from blinking to not blinking. So this timer, I mean, it's really like a blink timer, I guess. It's true. I mean, that's its function. Currently, that's what we have. What are the other rules that we have? Well, we also keep track of the movement state, which has been defined as up, down, left, right, and idle. Okay. This sounded fantastic, and we're already saying, but wait, what about diagonal? Right? We're already saying, hold on, we never drew left frames. Okay, this is where it's starting to get to the root of the things we need to refactor. These 5 movement states seemed appropriate at the time, and maybe they are, but I have a feeling this could change. Let's question that. Again, we're free to change our rules, right? It's part of the design process. We run the timer, and when the timer is up, we do a thing. The timer is about blinking, and so we, if is blinking, right, then we stop blinking, or in other words, show the move frame. Okay. This made so much sense when it was just the character by itself sitting idle and just had to go between 2 frames. In fact, if you recall, this animation system came from the coin that was going through a loop of frames, right? It had these 4 frames, and it went through 0, 1, 2, 3, and then looped back, right? And that's where this animation system came from, where we modified it so it was just blinking, and we said, well, you know, there's 2 frames of blink, so we'll just do the same thing, right? Blink and not blink, right? Well, you see how this, you know, grabbing this code from an earlier test and modifying it for what we need right now made a bunch of sense. And now we're here saying, oh, wait, it no longer makes as much sense. So we did say, yeah, let's just show the move frame if we are blinking, but if we're not blinking, let's show the blink frame. This is the rule set we have. And then we said, okay, but what about this movement state? What are we going to do with that? And we said, whoa, okay, no big deal. The move frame we set comes from the movement state. So set move frame based on movement state, or so to the movement state, right? Yeah. So in other words, we are getting a signal about whether we're moving up, down, left, right, and we're using that to set the move frame. And okay, I mean, this makes sense. It actually looks fine, right? Here's where we start to run into issues, though. Because we also said, oh, wait, there's this one frame that's like right, and then there's this one frame that's like left, and it really is just flipping this image around. We're trying to be clever about it, and this is like a -1 scale, this is a +1 scale, and so we have to know, oh wait, are we moving left? And we'll remember that. So is going left, I think, is how we set it. And by default, this is false, but then we might go left, and if that's If we are going left, like we detect this and we say, then you are definitely moving left. Like if move state is left, I mean, you see where this is going. This actually ballooned into a crazy set of rules, and I know this can be simpler. If move state is left, then is going left is true. I'm running out of room because this got crazy. I mean, even with the rule set written out like this, it's crazy, right? I'll put the other rule over here. If move state is right. Now, specifically in the code, we said, well, we have to figure out when it's not left, and we say, well, it has to be when you actually go right. Okay, so if move state is right, then is going left, here, let's not a question, this is true. Okay, is going left is false. So, I mean, I'm already like rolling my eyes at this. Okay, let's review. And by the way, the signal we get for this information comes from our other totally fine working script about movement. And that made such sense. In fact, it figures out whether we should be saying up, down, left, right, and tells us, it actually sets our little variable here. Okay. Question. Could we simplify this list? Could we then use a simplified list of rules to make the character animation do what it does now in a way that is not a mess? Because here is some of the mess. This way that we're doing the turn left is a bit of a mess. I don't necessarily want to draw another frame. We don't need to. But I think the blinking mechanic is appropriate and works okay. It is the setting the move frame combined with the is going left jazz that is causing some weirdness, right? I don't mind saying, are we blinking or not? I don't mind the timer at all. But I'm already concerned when we say up, down, left, right, and idle are the only 5 states, given we may actually want to do something with diagonal. Oof. Should we add to this list of movement and blah, 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 blah? But this comes from another system. The move system already knows something a little more sophisticated than what we are saying. The move system actually knows the move direction. The move system actually has a public variable that is a vector 3. Now, I know, not doing code. But this does, frankly, have x, y, and z, and we can ignore the z. But it knows, for example, if we are going left or right, because this x will be positive or negative. Wait a minute, isn't that exactly what we do right here? Positive or negative x? Yes, actually. Couldn't we just say, make this game object of our character flip around based on whatever this x is doing in our move vector? Yes. Yes, we should do that. And maybe we are going to remember, have we gone left last? I think that's appropriate. But again, this could be based on the x value that the move direction already knows. And it also knows what's going on with y at the same time, which means it knows if we are going diagonal or not. Wow. This is limiting. It only has 5. This information is far more precise and detailed. It's more detailed than this. I almost think that our assumption that we should have the move system make a signal to the animation system was a nice guess, and now we realize it should probably just be the other way around. Instead of a signal going to the move system, instead of that, let's have, in fact, we don't even need a move state at all. Let's have the animation system ask what is going on with the move direction. In fact, let's go look at that when we need to set, are we moving left or not? Right? Excuse me, correct? More than that, we could be frame by frame deciding about the orientation, left to right orientation, based on this. Like, we could just have a reference to the move system script instead of the other way around, and be looking at this public variable all the time to do things like orienting the character left or right. And we can remember, have you gone left last? That's fine. We could do that. We could keep this. This is cool. But I say this is going to be gone. I say we get rid of this. I don't think we want this anymore. I loved the idea of a state machine. In fact, having, wow, hold on. Let me back up. A state machine is a really good idea for animation. And in fact, if in the future we decide to do more than just one frame for moving to the left or idle, then having a state is actually a really smart thing to do, because we can loop inside one state a set of frames like this. You know, it's not a coin, it's a character. And this would be an idle loop, and then we have a right loop, and we have a, you know, we could do that. If we did maintain this movement state, I say we can go have a mechanism ask, again, what is going on with our move direction? And we will set it ourselves. Like, we had it all calculated here in the move system for the animation, and I say it's the other way around. It really, now that we're looking at it, let's go ahead and have the animation system ask movement. How are we moving? And based on that, I'll set the movement state, maybe use it later. Cool. I think that's one of the refactor things, is let's switch the direction of the communication. Okay, let's go ask the move system what's going on, instead of sending information to the animation system in the form of this very limiting piece of information. We could still use this. I think for future animation state stuff, I think it's actually useful. So this is what it means to refactor. We are rethinking these rules. Now that we understand more of what's going on, we realize, wow, this going left stuff, right? Tell you what, if we know that we should be flipping our sprite around to look like it's going left and setting our scale to -1, because we're looking at this number, our game object of our character will stay there as long as the rules don't say to change it. Right? We could have a rule that says, go look at the move direction and set our movement state, and then use that same direction to determine, based on this X, how we should orient our character. In fact, let's just set the character's X scale based on whatever this is. And that's a pretty simple rule. I'm going to add it right here. Set character X scale. In other words, the scale in just that one axis. We're going to flip it horizontally with the X scale based on movement direction. And this is a pretty simple rule. It is look at that value and set that value here. Do that every frame. This is handled every frame. I think that'll work. If we do that, where based on movement direction. Okay, I got it. Hold on. I'm thinking about the rules. Rapid prototyping, right? If, right? If the X move direction is not 0. Now, this is significant. If the move direction was 0, it's because we're moving up or down. It means that we shouldn't change which way our character should be oriented. The way that we have this character moving now, which is something we want to keep, if we are remembering the left and right movement and we go up, right, it's so that we can orient the body in the right direction so that up and down is oriented based on what we last did in terms of left or right, you see. This is the behavior we want to keep. I'm saying we don't need to explicitly remember have we gone left last if the game object itself is already oriented that way. If our move direction in X has a 0 in it, or let's say it's not equal to 0. This is actually how we say not equal to. If it's not equal to 0, then we orient the character scale. Character X scale equals move direction X. So this took a little bit of thinking through, but what we're saying is if we're going up or down, this is going to be a 0, and we shouldn't really do anything with our character. But if we're not just going up or down, if we are moving at all to the left or right, this will change and be either a -1 or a +1, and then we should change this. This will maintain that scale until it's changed again, which is another way of saying it remembers if it went left. It remembers if we went left or right last. So suddenly we don't need any of this. We actually don't need any of this if we use the character itself to remember whether we were going left or right. Okay. This means there's one rule now that we didn't have before that takes the place of a few rules we had. That should actually clean things up. Set the move frame to the movement state. I wonder if move state is useful still, at least until we get some more animation frames to show and have some more reason to have a state machine. If what we do instead is say, how does our character move now? I mean, again, we are keeping this functionality. Clearly, up, down, left, and right. We are setting to those 4 directions if it's just that. Now, what happens when we do diagonal? We are currently saying, well, left and right have priority. And we did that by, I think, the order in which the rules are being paid attention to. Like it also knows that I'm going up or down, but it is really only paying attention to the left or right part of it in order to decide what frame to show. So we want to maintain that. I mean, I already like the fixes we've been doing here, but is there an opportunity right here? Blinking, yes. Timer, yes. I like this. This, I think, is still around. I think we need to keep this around only because I anticipate we might do something with animation in the future. Maybe not tomorrow, but the future. Setting the movement frame to this is okay, but let's consider we're already looking at this move direction stuff. What we have are frames that look like idle, and we have right, we have up, actually, yeah, we have up, and we have down, and we have right, and we have left, right? We don't really have left, though. We don't have a left frame. Let's not confuse the issue. We are either moving left or right. So, let's look at it this way. The only time we show idle is when we're not moving at all. The only time we show up is when we're only going up. That's currently what the animation system is doing. If we're going up and to the left or right, we actually show left or right. If we're going only down and nothing else, that's when we show the down frame. The rest of the time, we are either showing left or right, and it's actually already flipped around. I think this is much simpler now. Setting the movement frame to be based on this move direction, like both X and Y have to be 0, right? Or 0 in X for these two, right? Otherwise, we show this. This is a simpler set of rules. Check it out. If X and Y are both 0, then we are idle. If X is 0 and Y is not, then we can go down the road of if it's a positive 1, we go up, and if it's negative 1, we go down. Otherwise, we are definitely showing this frame of moving, and we are already flipping it left or right, so we don't care if it's called left or right. It is just this frame. You recall, in our code, we actually put an extra set of frames for right and for left, which is totally unnecessary if we look at this cleaner set of rules. This is, we're not going to do this anymore. We're going to do this now. Set move frame. This is a cleaner set of rules to figure out which frame should we be showing. Based on the move direction, if both are 0, we're going to show this idle frame. If X is 0 and Y is 1, then we'll show up. If X is 0 and Y is negative 1, we'll show down. Otherwise, we are absolutely going to show this moving to the right frame and let the positive and negative scale already done for us be handled. Consider for a moment, we could not rely on that part of this rule without this extra rule that we just did being in place. This refactor caused us to untangle a bunch of things, but now I think we actually have a better set move frame, but it's a different set of rules. I think we have sketched out or paper prototyped a new set of rules that does what we see here, like the functionality staying the same, but in a much simpler way, which is beneficial because in the future when we plan to make changes, this will accommodate change much easier. This was a mess before. It is much less of a mess now. We're going to make 3 big changes. First of all, we're going to stop the move system from communicating to animation and instead have animation ask what's going on with the move direction for everything we need to do. We will set the movement state that way. We will also, too, have this move direction handle the scaling of our character, which is also going to remember if we went left last or not, just by setting the scale. And because that scale is already set, we are also going to, 3, change the set move frame rules to this, which is a much shorter and simpler set of rules based exactly on what we have now. In other words, functionality staying the same, but so much easier to maintain. That is called refactoring. This is something we will come back and deal with in our design workshop, but refactor is the word for today. We've been playing around in our prototype. We built it up to a point that was like, well, this looks right, but wow, what a mess. And we found out so many things along the way that this mess needs to be cleaned up. So refactor now allows us to maintain that functionality, but now with a new set of rules that we're going to implement that, believe it or not, is going to clean up a lot of this stuff. And it'll be much easier to make changes in the future because we are expecting change. We're always going to improve. This has been a Cartoon Ape talking about design. This is a best practice, not just prototyping and rapid prototyping, but refactoring. And as much as we're talking about using this refactor in terms of code when we do the workshop, this is actually as much a job for the designer as it is the programmer. How crazy would it be to have all these contradictory rules and fiddly things involved when you're just trying to follow the rules of a game? As a player, that would be nuts. You would want to have a simplified set of rules to explain to the player, to have the player understand a simpler set of rules. Same for us. While we're developing this game, and we're expecting to make changes in the future, let's not make it complicated for ourselves. To make those changes harder is not a smart thing. Let's spend the time to make the rules simpler, just so when we need to make changes, those changes are easier to do. Refactor. If you're interested in watching a Cartoon Ape talk about game design, make games, or play games, then follow and be notified. And when you show up on stream, please do me a favor, do Command Tie. Command Tie lets me know you're here, and I can say you are here. In the meantime, have fun, do well, be good, stay safe. Happy holidays. See ya.